Let us solve a problem for the axis symmetric element. Given problem question is about develop the stiffness matrix for the axis symmetric element shown in the figure. Take E as 2.1 into 10 to the power of 6 Newton per mm square and Poisson's ratio as 0.3 and all the dimensions are in mm. This is the given figure. As we already know, for the axis symmetric element, we will be taking the axis as R and Z. Let us first note down the given data. Young's modulus E is given as 2.1 into 10 to the power 6 Newton per mm square. Poisson's ratio mu is given as 0.3. So, coming to the find outs, we have to find out the stiffness matrix. The formulas for finding out N1 and N2, N3 and the R and Z are given. From the figure, note down the values of R1, R2, R3, Z1, Z2, Z3. Considering this as point 1, where X is R1 and Z1. Considering this as point 2, where X is R2 and Z2. Considering this as point 3, where X is R3 and Z3. So from the figure, R1 is taken as 0, Z1 is taken as 0, R2 is taken as 50, Z2 is taken as 0, R3 is taken as 0 and Z3 is taken as 50. As we got the R1, R2, R3, Z1, Z2, Z3 values, we can now calculate R and Z from the formula R is equal to R1 plus R2 plus R3 by 3, Z is equal to Z1 plus Z2 plus Z3 by 3. By calculating R values and Z values from the calculator, we got R as 16.66 and Z as 16.66. Now calculate the values of P1, P2, P3, Q1, Q2, Q3, R1, R2, R3. Capital P's, capital Q and capital R's which are required for the formula here in the N1. P1 plus Q1R plus R1Z by 2A. So here we need P1, Q1, R1, P2, Q2, R2, P3, Q3, R3 values. For calculating P1, Q1, R1, P2, Q2, R2, P3, Q3, R3, the following are the formulas. For P1, R3Z3 minus R3Z2 gives you the P1 value. Similarly, for P1, capital P1, capital P2, capital P3, capital Q1, capital Q2, capital Q3, capital R1, capital R2, capital R3, the following formulas, the values can be substituted to obtain the values. For the 2A value in the formula, N1 is equals to capital P1 plus Q1R plus capital R1Z by 2A. For the 2A, we have the formula R2Z3 minus R3Z2 minus R1 of Z3 minus Z2 plus Z1 of R3 minus R2, which is nothing but the area formula, area of the triangle formula, where the half on this side is sent to the that side to get the 2A value required for the formula. By substituting the values of R1, R2, R3, Z1, Z2, Z3, we'll be getting the value of 2A as 2500 and value of A as 1250. Substitute all the values of capital P1, capital P2, capital P3, capital Q1, capital Q2, capital Q3, capital R1, capital R2, capital R3 in the formula to get capital N1, capital N2 and capital L3. So we have got all the required values. Now to calculate the stiffness matrix for this axis symmetric element, the formula is K matrix is equals to matrix of B transpose, matrix of T, matrix of B multiplied by area multiplied by 2 pi R. Here K is represented for the stiffness matrix. A denotes the area which we have calculated earlier. R denotes the value of R which we have calculated earlier. Now we have to calculate B transpose matrix, D matrix and B matrix. Coming to the formula or the matrix for B. The matrix for B is stated as follows: 1 by 2A into matrix of. We'll first know how many rows and columns this matrix contains. 1, 2, 3, 4. 4 rows. That is 4 into 1, 2, 3, 4, 5, 6. So this is a 4 by 6 matrix. Substituting the values of Q1, capital Q1, R1, capital N1 and small r, which we have calculated earlier, you'll be getting the B matrix and also the value of 2A. Then coming to the B matrix transpose the 4 by 6 matrix. Transpose of a matrix means the columns will become rows and the rows will become columns. So subsequently you will be getting a 6 by 4 matrix, a result for the B transpose matrix. For the D matrix, we have the formula E by 1 plus mu of 1 minus 2 mu into 1 minus mu 0 mu 1 minus mu 0 mu 1 minus mu 0 0 0 0 1 minus 2 mu by 2. This is overall a 4 by 4 matrix where it has 1 2 3 4 4 rows, 1 2 3 4 and 4 columns. Substituting the values of E E and mu which are given in the problem statement itself, you will be getting the result of the D matrix as follows. Now coming to the multiplication to get the stiffness matrix, which is actually required for the problem solving. Let us now know the B transpose matrix is a 6 by 4 matrix. The D matrix is a 4 by 4 matrix. The B matrix is a 4 by 6 matrix. So you have to do the matrix multiplication carefully, because in normal numbers A into B or B into A is same. But coming to matrix A into matrix B is not equal to matrix B into matrix A. This is one of the properties of matrix multiplication. Coming to the multiplication of matrices, substitute B transpose matrix, which is a 6 by 4 matrix. Substitute D matrix, which is a 4 by 4 matrix. And never ever forget the constants you have before the matrix. They are also a part of the matrix. You can multiply this sub constant values all together with these values, 6 by 4, 4 by 4, and then multiply with the B matrix, which is a 4 by 6 matrix. Now initially multiply the 6 by 4 matrix and 4 by 4 matrix. The trick here is when you multiply two matrices of different number of rows and columns, here M1 into N1, M2 into N2. The resultant matrix would be M1 into N2. That is, the resultant matrix would be a 6 by 4 matrix. So initially multiply these two matrices to get a 6 by 4 matrix. To multiply matrix of this range in a calculator, you should have a Casio FX991EX calculator. Click on button, click on menu or setup, right click the button to go into the matrix column and click is equal to button. Automatically you will be converted into matrix format of the calculator. Since you have two matrices here, consider this as mat A and consider this as mat B. The order of, so initially we have to define the matrix A and the matrix B. Click on 1 and it asks for the number of rows of matrix A. Number of rows are M1, that is 6. But this calculator is compatible only for rows 1 to 4 and columns 1 to 4. In that case, for a matrix which has more than 4 rows or 4 columns, divide the matrix into 2 subsequently possible matrices. Here we have 6 rows and 4 columns. 4 columns is possible in this calculator, but 6 columns is not. So divide the 6 rows is not. So divide this 6 rows into 4 by 4 a matrix and 2 by 4 a matrix. Similarly, we then get minus 50, 0, minus 50, minus 0 0.04, 0, minus 50, minus 50, 0, minus 50, 0, 0, 0 0.02, 0, 0, 50, 0. This is the 4 by 4 matrix you get, and the other remaining part is the 0, 0, 5, 0, 0 0.02, 0, 5, 0, 0, 0. This is the matrix you get. Now individually multiply this 4 by 4 and 2 by 4 to this 4 by 4 matrix which we are looking here. As 4 by 4 is subsequently compatible in this EX calculator, first initially, because the result you get is subsequently a 6 by 4 matrix, right? So initially multiply this 4 by 4 with this 4 by 4. So select 4 and 4. Give the values of this matrix. Minus 50 and click minus 50 and click on is equal to, and give 0 is equal to minus 50 is equal to minus 0 0.04 is equal to 0 is equal to minus 50 is equal to minus 50 is equal to 0 is equal to, this is 50 is equal to 0 is equal to 0, 0 0.02, 0, 0, 50 and 0. This is the 4 by 4 matrix. Now click on button. So your matrix A will be saved. Now again do the same process. Go to matrix, click on 2 number to give this 4 by 4 matrix so that you can perform operations. Similarly, 4 rows and 4 columns. 0.7 is equal to 0.3 is equal to 0.3, 0, 0.3, 0.7, 0.3, 0, 0.3, 0.3, 0.7, 0, 0, 0, 0 and 0.2. Again click on button and your matrix B will be saved. To perform multiplication, go to operation, click on matrix A, right? We have to multiply matrix A to the matrix B. Click on matrix A, that is 3, and click on multiplication symbol, and then click on option again, and then you have matrix B here, right? Click on 4. Click on is equal to get the required matrix result. This is the matrix result that you have to note down. Let us note down this from the calculator. This is the first, as you have to get a 6 by 4 matrix. As a result, you have got the first 4 rows, and obviously you have 4 columns and the 4 columns. So note it down from the calculator. Can you see the values here? Minus 50, minus 30, minus 50, minus 8 into 10 to the power minus 3, minus 30, minus 50, minus 50, 0, 35, 15, 15, 4 into 10 to the power minus 3, 15, 15, 35, 0. This is the initial 4 by 4 part you have got. Now if you multiply this 2 by 4 to this 4 by 4, initially I told you the trick, no? The resultant matrix would be a 2 by 4 matrix, which completes the 6 by 4 matrix. Now again click on menu or setup, go to matrix, click, as you have already defined matrix A and matrix B, click on C, that is 3 matrix C. We have 2 by 4 matrix, right? The number of rows are 2 and the number of columns are 4. Now define the matrix. It would be 0, 0, 50, 0.02, 0, 50, 0, 0. Now click on button to save the matrix. Now you have to multiply, this is matrix C, right? You have to multiply this matrix C to this matrix B. Never ever confuse and multiply matrix B to matrix C. Because if you multiply a 4 by 4 into 2 by 4, you get a 4 by 4 matrix. But here we need a 2 by 4 matrix, and that is the correct procedure. So again, matrix multiplication, click on option, click on matrix C, which is 5, click on multiplication symbol, and again go to option, click on 4 matrix B, and you get the 2 by 4 matrix. Now this completes the 6 by 4 matrix required for the initial multiplication. See, we have got the 6 by 4 matrix. Now this 6 by 4 matrix is multiplied to this 4 by 6 matrix. 6 by 4 into 4 by 6. You get a 6 by 6 matrix. I'll tell you how to do this 6 by 4 and 4 by 6 matrix in a calculator. So after multiplying all the constants, the constant value is 0.084 into 10 to the power 6, and we have two matrices, 6 by 4 matrix and a 4 by 6 matrix to multiply. So initially from the trick I told you, we get a result of 6 by 6 matrix. 6 by 6 matrix as a result for the stiffness matrix. So here, to do this matrix carefully in using a calculator, you have to divide, you have to perform multiplication 4 times in the calculator. That is, you have to divide the whole 6 by 6 matrix into 4 parts. Initially, after multiplying 2 matrices, you will be getting a 4 by 4 matrix, and then you will be getting a 2 by 4 matrix, and then you will be getting a 4 by 2 matrix, and then a 2 by 2 matrix, which completes to get a 6 by 6 matrix. I'll teach you how to multiply them. Initially, consider this matrix, initially how we consider as a 4 by 4 matrix, and a 4 by 4 matrix from this 4 by 6 matrix, this 4 by 4 matrix, and save them, 4 by 4 matrix. So initially you have saved 2 matrices, right? To get rid of them, just click on menu setup, go back to calculate, and then click equal to. All your saved matrices will be deleted. Now again click on menu setup, go to matrix, click on 1, how many rows? 4 rows, 4 columns, and start giving the value of the matrix. The values are minus 50 is equal to minus 30 is equal to minus 50 is equal to minus 8. Here there is an option of into 10 to the power x. Use that option, 10 to the power minus 3. And then minus 30, minus 50, minus 50, 0. And then we have 35, 15, 15, 4 into 10 to the power minus 3, 15, 15, 35, and 0. So your matrix A is saved. Now again, you have to give this 4 by 4 matrix, right? Click on matrix, click on 2 to give the matrix B. You have to give 4 rows and 4 columns. Start giving the values, minus 50, 0, 50, 0, 0, minus 50, 0, 0, minus 50, minus 50, 0, 50, minus 0.04, 0, 0.02, 0. This is matrix B. Click on button. The two matrices are saved. Now time for matrix multiplication. Click on option 3. You get matrix A multiplied by, click on option again, and 4. You get the 4 by 4 resultant matrix. Note down this matrix onto your paper. That is 5,000, 4,000, minus 2,500, minus 2,500, 4,000, 5,000, minus 1,500, minus 2,500, minus 2,500, minus 1,500, 1,750, 750, minus 2,500, minus 2,500, 750, 1,750. So you got a 4 by 4 matrix, right? Now multiply this 4 by 4 matrix again with this 4 by 2 matrix. So what do you get? Here 4 by 4 into 4 by 2. You get a 4 by 2 matrix as a resultant. So again, go to the calculator, click on button, go to menu or setup matrix, click on 3 as matrix C, where you have to load. Already the 4 by 4 matrix is loaded into the calculator. Now you have to load this 4 by 2 matrix for multiplication. So number of rows are 4, number of columns are 2. So 0, 0, 0, 50, 50, 0, 0.02, 0. Okay, click on button. Again, go to option. Click on 3 matrix A multiplied by option. Don't confuse. It's the matrix C this time. So into number 5. So matrix C into matrix C. You got the result of a 4 by 2 matrix. So you have to note down the matrix here. Okay, because here if we multiplied this 4 by 4 matrix with this 4 by 2 matrix, and you get the element just beside this 4 by 2 matrix, right? Because you have 4 columns and correctly 2 rows balance here. Minus 2,500, minus 1,500, minus 2,500, minus 2,500, minus 750, 750, 1,750, and 750. Still we have 2 rows balance here, right? For the 2 rows, initially you have to multiply this 2 by 4 matrix to this 4 by 4 matrix. So 2 by 4 matrix into 4 by 4 matrix gives you a 2 by 4 matrix, right? So now click on button, go to menu or setup, go to matrix, click on 4 as matrix D, where you have to give a 2 by 4 matrix, right? So number of rows are 2, number of columns are 4. So 15, 15, 35, 4 into 10 to the power minus 3, 15, 35, 15, 0. So your matrix D is loaded. So initially, remember, this is matrix A, this is matrix B, this is matrix C, and this is matrix D, right? So you get the starting portion here, that is a 2 by 4 matrix here. You have to multiply this 2 by 4 with this 4 by 4, that is D into B, matrix D into matrix B. So go to menu or setup, no need, go to option, click on matrix D, that is 6, into matrix B. What is matrix B here? 4. You get the 2 by 4 matrix. Note it down here. 2,500, this 2,500, 750, 1,750, minus 1,500, minus 2,500, 750, and 750. Still we have a 2 by 2 matrix balance here. So you get that by multiplying this D matrix with this C matrix, that is 2 by 4 into 4 by 2. Obviously you get a 2 by 2 matrix. So D into C, again go to option, matrix D, that is 6 into, go to option and C. You got a 2 by 2 matrix. 17, note it down. Remember to mark what is the matrix name you have given. Some people may take this as A matrix, some people may take this as B matrix. It depends on choice. So the order of loading your matrix into the calculator should be remembered for the accurate multiplication of matrix. So finally we got the 6 by 6 matrix, which is the stiffness matrix required for the axis symmetric element. Let us check it with the answer. Look at the answer. So this is the 6 by 6 matrix, stiffness matrix for the given axis symmetric element.